9.2.1, we're looking at arithmetic sequences. So we talked before about sequences, and we started with an example 3, 6, 9, 12, 15, I think was our first example. And that is actually, coincidentally, an example of an arithmetic sequence, because every time you start with one number, 3, and every time you add the same number. So if you start with any number and then to get to the next number you just add the same number again every time, that is an arithmetic sequence. It's also possible to have it be that difference of 3 between each term. That's called your difference, the common difference, which we call D. And it's also possible for D to be negative. For example, if I had starting with 5 and going to 1, and then going to negative 3, and then going to negative 7. So there's still a common difference here. I keep going down by 4. So I'd have a D of a negative 4. It is important that we check several terms to confirm that it is in fact a sequence in arithmetic sequence. So let's look at our official definition here. A sequence is arithmetic if each term in the sequence is found by adding a real number D, even if D is negative. These could be positive or negative, to the previous term, so that it actually can be expressed as a recursive formula where we have A of n plus 1, I'm sorry, not A of n, A sub n plus 1 is AN plus that difference. So you take your previous term and add D. Okay, so D is a common difference between each term. All right, let's look at some homework problems. So you're doing 1, 5, and 9 from this. There's a couple sections of homework on this part. Well, just 2. So you're doing 1 through 20, every other odd. So from this first section, you're looking at 1, 5, and 9. So for some examples, we'll do 2, 6, and 10. So let's look at number 2. So we want to determine the sequence, determine if this sequence is arithmetic, and if it is, we want to find the common difference. So let's see. So that means I start at the first term and see what would I add or subtract to get to the next term. So in this case, I subtract 3. And if I do that all the way through, then it will be arithmetic. So repeating 6 to 3, I can subtract 3. 3 to 0, subtract 3. 0 to negative 3, subtract 3. So yes, I can see that there is a common difference. So here D is a negative 3. So yes, it is arithmetic. And then going on to 6. Let's change colors for 6. So going on from 0.7 to 1.2, that means I'd have to add 0.5. And 1.2 to 1.7, I could add 0.5 again and again to get to the 2.2. So yes, this one does appear to be arithmetic as well. And my common difference is 0.5. So notice that the difference can be negative, it can be a fraction or a decimal, as long as it's the same between each element of that series, or sequence, I'm sorry. All right, let's look at number 10. On number 10, the difference between the first two terms is, whoops, not a square, not a rectangle. It is 60, minus 60. So let's see if that continues. And then 60 to 30, that difference is negative 30, and then negative 15. Those differences are not common. So this one is not an arithmetic sequence. So I cannot name a D. So that's 1 through 10. And then the next section we're doing is 11 through 20, where you're doing 13 and 17 from here. So for 12, let's read the directions first. Okay, we're going to find the first 4 terms of the sequence, and then we'll determine whether the sequence is arithmetic, and if so, what that common difference is. So let's figure out what those first 4 terms would be. So when I plug in a 1, a 2, a 3, and a 4. So if I plug in n equals 1, I get 3 times 1 minus 10, which is negative 7. If I plug in n equals 2, I get 2 times 3, which is 6, minus 10, which is a negative 4. If I plug in 3, I get negative 1, and if I plug in 4, I get a 2. So do these have a common difference? Let's see, negative 7 to negative 4, add 3. To go from negative 4 to negative 1, I add 3. To go from negative 1 to 2, I add 3. So yes, this has a common difference. The common difference is 3. So we determined that yes, it is arithmetic, and the common difference is 3. And number 20. So we have an alternating. Remember, with our negative 1, that means we're alternating. I'm going to write the first four terms again. So I have n equal to 1, 2, 3, and 4. And then my first 4 terms, when I plug in a 1 for n, then my sign, that means that this exponent will be a 2, which means this thing will be a positive 1. So I know I start with a positive, and it's going to alternate, so it goes positive, negative, positive, negative. And then 2n, 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, and that's all negative. Okay, so let's see. To go from positive 2 to negative 4, I would have to subtract 6. And then to go from negative 4 to positive 6, I would have to add 10. These are not equal, so there's not a common difference. So that means that this is not arithmetic. And that wraps up 9.2.1, introducing the arithmetic sequence.